Hello and welcome to another Solana tutorial. Today we're gonna have a look at yet another Claude model, Opus 4.8. Now you might be wondering, why would I have a look at that model? I just had a look at Fable 5. And the answer is, well, Fable 5 is not available anymore, so Opus 4.8 is the strongest currently available model. Because yes, after 3 days, they took away access again because it was too scary. Yes, it was just too good of a model. It was breaking too many things and giving people access to too much power or whatever. So, well, we ain't got Fable 5 anymore. So Opus is the strongest model for Claude Code. And I also made a video once where I was actually using the model a tier below that actually, Sonnet. And there I was arguing that, well, Claude Code is also making mistakes. We're just not there yet. Because I let Sonnet build a Solana program, and that didn't turn out so well. I could still outsmart Sonnet. I couldn't outsmart Fable anymore. So that's why now I want to know, where does Opus stand in all of that? Can Opus write a Solana program that is solid from a functional and a security perspective? Or should Opus rather be used as a support tool to help you build your Solana programs, but by itself it's not fully capable of doing it? Because Fable was fully capable. Fable, I said, built me that Solana program, it downloaded all the dependencies it needed, it wrote the program, and it worked, and it was secure. And I was amazed. So yeah, now we're gonna do the same thing, but with Opus. Same thing. And I'm curious where we land. Because this is the deciding moment, right? This is, does Claude win or do I win? It's 1-to-1, basically. Like, how smart am I in the spectrum of Claude models in terms of Solana development? This is what we're really analyzing today. Okay, so here we go. So last time we did this, we built a sandbox. I'm gonna do the same thing again because I don't fully feel comfortable letting Claude Code have access to my entire machine. So we're gonna do that again. So first we're gonna open this in WSL, create a dev container, and inside a dev container JSON with this same file, just that now it's an Opus sandbox. Fable, by the way, is spelled like this. I misspelled Fable. And then we're gonna reopen this in a container. So we're starting Docker. Yep, let's go. Cool. Just like that, we are in our sandbox and we have the extensions installed. Hehe. Good. And one login later, we got Claude Code and we can make sure that we're on the right model, the one that we actually want to use today. So we see Fable 5 is currently unavailable because the US government was like, nah, you gotta suspend that. Yeah, well, that happened. But basically, I'm just here to show you we're in a new session. It was just Monday, my credits reset. It's a completely new session in the Pro account. And we see how fast we burn through credits with Opus. And yeah, I would say let's just get started. So, because I'm pretty sure that last time I didn't pay attention to the models and I used the default, which is Sonnet, which is good for everyday routine, the tasks, right? Give it a quick task, give it something to fix, it will do it for you. But for more complex tasks, you probably want Opus. Best for everyday complex tasks. And Fable, that we had a look at in one of the previous videos, already got disabled because it was just too good. So, Opus it is. And I have the exact same text that we did last time. Although, actually last time I also started with, hey, can you tell me which model we are currently running? Just to see if that also costs me so many credits if I just ask a quick question. So that was a quick answer. We're currently running Opus 4.8. Comparing to Fable 5, both are the most recent generation of Claude models. They're positioned differently. Flagship Claude 4 and Fable 5 is a separate new model line, latest release, but it's a distinct family rather than bigger or smaller tier. Okay, distinct family. On Claude Code specific note, fast mode gives you Opus with faster output, and importantly, it does not downgrade you to a smaller model. Are we currently in fast mode? No, we have thinking on. We have effort high. I could, ultra code, max, extra high, low, high, extra high. I don't know what to do with those settings. Should I set it to extra high? I definitely want thinking. Like it should think about what it's doing. It should first generate some text coming up with ideas and not just start working. And toggle fast mode. Did I now turn it on or off? Now we're in the console. It opens the console, toggle fast mode. Oh, it wants me to log in here. Okay. Fast mode requires usage credits to turn them on. Fast mode off. Okay, good. I don't want fast mode on anyway, so I guess that's cool. Great. Now, what did that cost us? Literally nothing yet. Like, we're still at zero. We're still at zero even though we asked something, so it's all good. This model by itself is cheap. Cheaper than Fable. Good. New session. Pick the model. We're on Opus. And we are on extra high effort. Okay, so let's see if Opus on extra high effort can build the same Solana program that I asked Sonnet and Fable to build, which is this Solana coin flip program. I keep coming back to this because that's a great benchmark for me. See what it comes up with here. That's the exact same text that I gave the other models as well. We are in a sandbox. It shouldn't have the context of what I did previously. Actually, one more thing. What do you know about me and my previous work? Just checking. Yeah, try and read something. It's trying to read something from file. But yeah, there's nothing here. We're in a sandbox. Just print it, let it print something else. It printed personal information that I don't want it to print. But it says my memory store is currently empty. There's no saved memory files. I have no persistent notes of you or your previous work or earlier sessions. That's great, so it can't get the idea of how to properly implement that from something that I did with Fable. Good. And then it prints my email address, so I'm not going to show you back to this session. Now that we confirmed that it doesn't have memory, same exact task, different model. Let's go. We will see what happens here. I told it to make some effort, so I'm assuming that this will be comparable to what Fable produced. Potentially, it's gonna struggle a little more, but it will come to a similar or the same output. Maybe not the same, but similar, I assume. But I'm not sure. That's why I'm testing this. In the 3 days of when I had Fable available, I played around with it with my OpenClaw as well. And Fable just got the things right. Opus also usually got the things right, but it was sometimes struggling with some details. If some authorization step was complicated, then it got hung up there and wasted all my credits on it. Where Fable was just like, yeah, that's the problem, that's the solution, here you go. So, yeah. But for that program, the critical part really is that coin flip, that you need to know that you need to separate it in two transactions, and that you need to find a proper way to get pseudo-randomness on chain. Those are the two challenges with this thing. So we'll see how well Opus deals with that. I told it to put in a lot of effort, so that's why it's gonna think a lot. But then, yeah, this is the strongest thing that we have available to us with Claude Code currently. So let's see how it does. First of all, it reads all of my project stuff. Yeah, it reads that it's in a dev container. Maybe it wants to escape already. Maybe it wants to already jailbreak. Sure. Or it just reads the environment to know what it needs to install. No Rust Solana Anchor toolchain. I kick off a Rust install in the background and design the full program. Great, yeah, do that. So it also understood that it needs to install Rust Solana and Anchor. Probably because it will create an Anchor program, but so did Fable. So, I mean, fair. I didn't tell it to be like super efficient. Did I tell it to you to be super efficient? Nope, I just told it to not make the program exploitable. Yeah, so Anchor is fine. And you see it's already installing Rust and it's already starting to eat into my credits. But pretty minimally, actually. With Fable, that went up quicker. But also Fable produced results a bit quicker, I think. Although now we're just waiting for Rust to install. Output is written to temp Claude 1000. What do you do while it does all your work? You wait. Cool. Now it's to create an Anchor project. Conflict, programs, conflict, source. Sure. Let's go. Let me first record my design decisions in the memory node and then write the code. I am curious about that. Okay, we're starting with state. Let's go. I'm gonna allow you edits in the session and then we'll check it out. So state. Okay. While you write this thing, I will read the code. So we've got a config with some stuff. We got a treasury that just stores the bump, and we got a bet. We got a bunch of errors. Now it's writing the main logic. That's where the juicy parts live. Oh, it's writing lib. Look at that. Wow, it even starts with Why the native version is exploitable. How this program prevents it. Commit reveal over a future slot. There we go. It understands that it needs to do a commit reveal scheme. Then it simplifies the player account validation. Yeah, sure, whatever. Slot, it works with slot hashes. Wow. Okay, we have an initialize, we have a fund treasury, we have a place bet, and we have a settle bet. And we have a withdraw from treasury. Okay, outcome resolution. Not ready, expired, or the 32-byte hash to derive randomness. Interesting. There's the resolve decider, so that's where it gets interesting. Oh, whoa, what it's doing now? It's writing TypeScript. Oh, integration tests. Great. A deploy script. Great. Love it. Sure. Go ahead. I mean, it can write programs faster than I can understand them. There's a move Lamperts. It's not bad. It looks solid from the design. The interesting part is the resolve decider. Wait, now let me try to verify Rust compiles. Okay, now that it wrote the program, it tests Rust and then it will build it probably. Yeah, sure, go ahead. And we wrote the program 16% of credits of the session, 2% weekly. That's not bad. So we could write like 6 programs in a session. That's solid. So the data comes from some slot hash. And then it takes a number from bytes, first 8 bytes of the data, the newest slot, oldest slot. If decide slot is bigger newest slot, then we're not ready. And if the decide slot is less than the oldest slot, then we're expired. Okay, we'll understand it later. What is it doing now? Cargo check exited with 0, but it seems to have a different problem. Let me fix a warning. It's so fun. I don't have to do anything anymore. Vibe coding. Now we install Solana toolchain. While that installs, let me do a careful review of the full program to catch any runtime issues. So this is now, can it compile? Check. Meanwhile, let me see the README. Actually, let me preview the README. This is reference educational code. Read the security model and residual trust assumption sections before deploying. This is so great that it gives me that as a warning. Ah, very nice. The hard part, it understands what's the hard part. The randomness. That can't be game. Because Solana execution is deterministic. Ah, ha, ha. Fun. The logic holds up. Double settle is prevented by account closure. Bad ID prevents repay. So it did double check the program as well if it's safe. Now Solana CLI. And then we build SBF. And we install Anchor, and now Anchor test needs a Solana wallet keeper and node dependencies. So that's what it creates, I guess. Keeper created. That's the keeper it created. Cool. And I think now it's done. Look at that. That took how long? Less than 20 minutes. It cost me a good 20% of my session credits. And here's where we stand. Done and verified. Full Anchor program, written, type checks clean. Integration tests, README, security analysis. All done. What the program does: place bet, escrows the stake, so a bet, like you pay for a bet, and pins it to the compilation is done or whatever, and it woke up again. This is fun. Yeah, do it, whatever. And where was I? And pins the bet to a future slot, so that decide slot is a slot plus a delay. That's the same idea that Fable came up with, right? And Fable decided that it's a fixed delay of 2. And settlebet derives the result from the slot hash. 2 anti-drain mechanisms. No grindable randomness. It's commit reveal. The deciding slot hash doesn't exist when a bet is committed. So the better can't simulate and only submit winners. Yeah. Losers can't be dodged. Nice. Solvency invariant. Each bet reserves its potential payout up front and is rejected if the treasury can't cover it. So no run of the wins. Nice. Anchor failed to build. SPF build is working. So we have some dependency error with some time crate, but it will figure that out itself, I guess. Continue once the builds finish and then run the full Anchor test. Yeah. Meanwhile, we continue looking at the README because it figured out that the randomness is the hard part. So the real requirement behind treasury cannot be drained is the value that decides the bet must not be known or controllable by the bettor at the moment they commit their stake. Yes. And the design is to reveal over a future slot hash. That's a great strategy. Nice. It now also the SO file. Nice. Program is fully written. Valid on-chain BPF binary. Waiting for Anchor CLI to run the full on-chain test suit. So fun. So there's place bet and then there's settle bet. That's the reveal. Outcome is derived from the hash of the decide slot, and the decide slot is the current slot plus the decide delay. Read from the slot hashes sysva mixed with an identity Nice. Why this is not exploitable. Great. Now, security model. Build starts a local validator, deploys and runs. Cool. So now it's anchor testing with a local validator. Here's one thing that Opus is doing differently than what happened with Fable. Fable surpassed Anchor and was like, I will build this manually. I got this. And Opus is still using the tools that Anchor provides and installed the Anchor CLI and runs the Anchor test. Fable was like, nah, I'll compile it myself with the Solana CLI. Yeah, it's just one different. I don't know what's better. Maybe there's no better. It's probably all trade-offs. But, that's what I see. The bet reserves the bet, but only free liquidity covers it. Otherwise, it's rejected. Settle bet releases the reservation, paying the treasury or a player. Withdraw can only remove free liquidity. So there's basically the treasury has an allocation of how much it reserves, such that it can't go out of balance and then not pay winning bets. That's fair. Yeah. That seems fine. Anchor accounts are validated. No fund on set. So a permissionless cranker can't point payouts at themselves. Overflow checks are true. And we implemented checked arithmetic. Ha! Agave validator requires something which WSL2 kernel doesn't support. Oh, great. I'll install an older Solana to run the validator and rebuild the SO with its matching toolchain. Well, is that the right strategy? I could tell you to just deploy to DevNet because that's what I want to do anyway. But okay, fine, do that. As long as you're not wasting all of my credits, and we're under 30, so that's fine. Fine, install an old. It's one way to deal with things. It's not the cleanest way to deal with things, but yeah, schedule a wake up. I'll report back when it comes back. This is so fun. It just runs a test in the background and it's like, I'll be back when that's done. So basically it's like a set it and forget it. I'm like, please develop this program and I can come back after 2 hours and see if it's done. Or even after, I don't know, an hour it should be done, whatever, with all the testing, depending how big the program is. But you can actually, that actually basically works autonomously. You're like, hey, do this, and then it will just continue if you auto-approve everything. Rent is returned to player on close, independent on win-loss. Wait, so is the stake put onto the treasury in the first place or no? Win threshold is enforced. Residual trust assumption. Read before going to mainnet. The deciding value is the leader's block hash. A validator that is the leader exactly at the deciding slot could in principle grind the contents of its own block to buy a specific pending bet. That's also what Fable warned me about, and Opus also realizes that, but I guess that's a fair assumption to have. This is expensive and narrow, but it's a real weakness versus a cryptographic VRF. For high value deployments, replace the slot hash with a switchboard on demand or whatever. So it even suggests stuff. The two-phase commit reveal flow and the solvency invariant in this problem are exactly the scaffolding such an integration needs. So that's why I developed it like that. In the lib, it had this, where did it go? This resolve decider. This could be replaced by a proper VRF. Yeah, cool. Test instructions, build, test, deploy. Suggested parameters. This win threshold is this. And decide delay 1 to 4 slots. So it didn't make a hard decision, use 2 slots like Fable did, but it's like 1 to 4 slots is fine. 1 is the absolute minimum and 4 is where it gets rather slow because that's 4 times 400 milliseconds. And if you wait 1.5 seconds, I mean, it's still okay. So that's the maximum, but we probably don't want to wait longer for your result. So it's now... And that's what I mean. That's one of the main differences between Fable and Opus. Opus will also manage to write you the program rather quickly, but then it will struggle with some things for a bit. Some dependencies or whatever. Or maybe that's just because it uses Anchor. But hey, maybe that's exactly the reason why Fable chose to not use Anchor and go through CLI directly. Go through Solana CLI and not do the local testing like this. I don't know why Opus is doing it like that. Nobody knows. So now it's struggling with whatever. I don't even know what it's doing. I think it's trying to run the test. Auto mode. Claude will automatically choose the best permission mode for each task. Great. It's slowly eating in my credits. We're at 30% now. The build toolchain is Rust, so that needs that edition, breaks at my... So it's struggling with some dependencies now. But I kind of want to just let it go and let it do that thing and see what happens if it finally manages at some point and how long that will take. Because I mean, overall, the program it developed seems solid. We didn't test it at all, but from a quick look at the code, it seems like it thought about all the see, I'm auto-approving everything anyway. I'm in a sandbox. I trust that it can't escape and wipe my system. So like bet AI account info, treasury AI account info, player AI account info. Whenever you read AI, you're like, what is this? So if player wins, when does the player win? So I'll iterate fast. Pass failures, return quickly. But the program itself is solid, but the struggle with dependencies is real. The real blocker is Solana program, Borsche derived macro. So it's finding the issue, but then better plan, build with agave, but run validator with this. So build with the newest version and then run the validator with an old one. I could also tell it, it's okay, we can just deploy to DevNet, but it wants to use the local one, so I'll let you use the local one, sure. You do whatever. Both toolchains present. So interesting if you keep reading what it's doing. And all of that will, of course, add context. And the longer the session runs, the more tokens are in the back. And the more every single instruction, everything that it's doing will cost, because it has more and more context in the back. And so the more it works, even the small tasks cost more. So that's why this will keep going up faster and faster, the more context it just has. That's why if it struggles a lot and tries to find out stuff, that's not ideal, right? And that's why at some point you want to compact, but not yet. I let it do. I let it do its thing. Loaded Agave build successfully. Validator still up. We airdropped to the wallet. So it airdropped and it already got something automatically. That's why we have such a interesting number, I think. What did it do? Yeah, it airdropped 500. That's what I said. 500 it airdropped and 5 billion it already had. Because it's a local test validator. Great! End-to-end test suite is running against the live validator. I'll report final results when the suite finishes. Cool. Celebrating. Let's show the results. Excellent. The on-chain program logic works correctly. 7 out of 9 tests pass. 15 losses, 9 wins. The 3 failures are a test harness bug, not a program bug. And it changes some stuff. Now it updates the test. See, with that, it's quite quick. With fixing the test, and it's rerunning the validator from scratch. Now it's struggling to kill the... Oh, it was a false positive. But point is, it is struggling with things, but then also it figures out a way around it, whatever all of that is. Oh yeah, it does a airdrop again. So all of that takes a while. I don't remember that Fable did so many things, but maybe Fable just also didn't automatically test it all. But it did. I think it did, just not with anchor test. I'll deliver the final summary once the test run completes. Yes, please. Give me all that final summary. Because we're at 42% after an hour. All 10 tests pass. Empirical win rate is 45%. Maybe it's doing so much because I told it to put in high effort, but yeah, who knows. Cleanup complete. It's changing the README. Let me add toolchain notes. Toolchain notes. Verified on a bare Linux WSL container. June 2026. So at least it writes down its findings. Okay, so all 3 verification layers passed. The cargo check, cargo build SPF, and TS Mocker. It did all of those things. Did all of those tests. What it built took it roughly an hour to do that. It built the program, the tests, wrote the README, 2 anti-drain mechanisms, no granular randomness, and solvency invariant. I think that's what it understands when I say the treasury can't be drained, but you know, it's not what I meant. I meant that you can't have artificially more wins. Complete and verified on chain. Well, on chain on a local test validator, not quite on chain. Great. And all of that with 44% of a session on a Tuesday afternoon in Europe, because those sessions also change size depending on time of day. But it's a 5% weekly allocation. That I think that's more constant. So in conclusion, I could say that building this with Opus gave me, I would say, similar results from what I've watched so far, but it needed more time and therefore also more tokens, but the tokens are cheaper. So roughly, I think it's the same. Like if I would have done it with Fable, I would have needed the same amount of allocation, but Fable would have gotten me there quicker and it might have done a better job. I didn't fully analyze it yet. But the whole point I'm trying to make here is if you're doing difficult tasks, use the best model that you have available, because if I would have used Sonnet, then it would have probably also needed that much to get to the same result, and it would have just made more mistakes on the way that I either had to manually fix or it figures it out itself and fixes it. Same like Opus struggled with dependencies here. Fable didn't. Fable was like, I'll just use the right things. Or it got lucky, who knows, whatever. But that's one thing that I realized, right? Okay, I think I'm gonna pack this real quick because it's a bunch of stuff that we've been working with and all of the deployment and so on. It's just a lot of tokens that we don't need to always send back and forth. So a quick compacting is probably helpful. And then I will tell it, can you please deploy this program to DevNet? That's what we're gonna do next. Let it deploy to DevNet. Compacted. 180k tokens freed. Great. So now it just has this compacted script here and it can read up on the things as it needs it. Okay, let's do it. It will again check what versions it has available because that information it lost. The SO is already built. Yes. If I wouldn't have compacted, it wouldn't need to find those things again. But therefore I have a cheaper starting point, I think. Or maybe that would have still been in cache. But I think the cache is just 5 minutes. And if you wait more than 5 minutes, then you gotta pay it all again. Cluster is now DevNet. Check balance and deploy costs. We have 0 sol. And we need 3.8 sol. And it attempts to airdrop. The request failed. But I told it I will help it with the airdrop. Fable also didn't manage to do the airdrop. And that's actually good. Because if the agents could just get sol, they will drain the faucet really quickly. Please send to this wallet. About 5 sol. Sure, I can do that. Here, have 5 sol. I am human. Yep, done. Let's go. Continue. It's checking balance. It has 5 sol. Great. So now it's deploying the coin flip program to DevNet with Solana program deploy. Program ID is this. Deploy it. Let's verify it's live on chain. Does it do the testing on DevNet right away as well? Nope. It just deploys. Great. Deploy transaction. Nice. It's deployed but not yet usable. To actually take bets, you need to initialize and fund the treasury. And optionally publish the IDL on chain. I'd suggest the parameters. Oh, I set the parameters at the initialize. That's actually cool. I actually like that better than hard coding them. So that's nice. I wonder how it does the initialize and fund if I just say yes, let's do it. I'll write DevNet setup script that initializes the config and funds the treasury with 2 sol. Initialized and funded. Treasury holds 2 sol. There we go. I'll do full screen now. Deployed. Config PDA, treasury PDA. Nice. Cool. Can you build let's see if it uses Solana Kit and Kodama to build a quick script where I can place a bet. Also, how we're looking here. Not too bad, still at 50%. Compacting saved us a bit. Kodama can generate Solana Kit client straight from the Anchor IDL. The IDL fully encodes PDA seeds. Great. Let me install Solana Kit, Kodama, and TSX. Also using TSX. I also use TSX all of the time. And it's writing the Kodama generate script, and then it runs the generate script. And now we should have the client generated, source generated, source generated. Every time we get that wrong, but yeah, whatever, it's fine. And also needs Solana program client core. Let me check the PDA helper exports. Let me check the bet seeds shape. So it's now checking all the files to know how to properly write the client script. IBang, let's go. Render treats, its targets, package, write source generated under it. So let me point it at clients JS for a clean layout to regenerate. Nice. It found out that it always does that in source generated, and now it's just source generated. Great. Clean, but it did remove all of the clients. So if it does stuff like that, it could accidentally remove stuff that I don't want it to remove. But you know, I'm in a sandbox and it's the only thing working there, so whatever. What I'm saying is it has the power. With great power comes great responsibility, right, Claude? You know that. Now the companion settle script. Oh, we wrote the place bet. Where did you write that? Scripts. Oh, here. We're writing it into scripts. Now let's run it end to end against the live DevNet deployment. Place a bet. Let's go. Settle bet on DevNet. Bet ID 0. Full round confirmed on chain. Let me run a few more rounds to exercise auto-incrementing. And surface the win path. Place 3 more. Round 1 and 2 hit the win path. Great. Definite rate limit. Yeah, welcome to working on DevNet. We hit rate limits without a custom RPC. Great. I mean, that looks good. What we built, the generation scripts, the place bet and settle bet scripts, and we can use it just like that. That's so convenient. I don't need to do anything anymore. I can just tell Claude to, hey, write me a script for that. And then it will write me a script for that. Not super readable, that kind of script, honestly, but that was the same with Fable. I also looked at it and I was like, what is happening? But we have the essential things here, the find bet PDA, and then it's creating the instructions with the get settle bet instruction async, which it generated the client up here. So that comes from here and is imported here from the generated. Pretty cool. So yeah, I would say that's similar results to what Fable produced for us, just a bit slower. But is it really? And now comes the challenging part for me. Can I somehow find holes in this? Holes that I can poke where Opus didn't think about it. I mean, there's the one thing that Fable then came up with that Opus so far has not told me. And that was the thing with what if the slot doesn't have a slot hash? What if the slot isn't produced, right? That was one of the issues. It did come up with the thing where the leader has influence of the slot hash. And so a leader of the deciding slot could, manipulate that. Yeah. Let me read through the program and see what we find. The most interesting ones are withdraw treasury. That's a high impact one. If that has an issue, move Lamberts from the treasury to the authority, and the authority assigner that is in the config authority, so only the admins. If we initialize, we set that authority here. Okay, that seems solid. What happens when you place a bet? Only if the treasury can afford it. Yes, it works with the law. Okay, we transfer the stake into the bet PDA. So that's the bet account. It doesn't go directly to the treasury. It goes first into a bet account. That's different to the design of Fable, who just put it in the treasury right away. I think I could verify. Place bet would transfer to the treasury directly. Yeah. So settle bet outcome, the data we get from slot hashes, and that's the decide slot. So the resolver then decides the outcome, and the player wins depends on the outcome. If it expired, then the player doesn't win. Same as with a loss. So the player, in an ideal world, we would run the crank, but the player would need to settle the bet after decide slot is over before it expires. If it's not yet ready, then we throw an error, and otherwise it depends on the hash. So we have the seed, it's a hash of that hash, so the slot hash part, and then the bet in the player, and that is again hashed. And we take the first 8 bytes as a U64 and do modulo 100, and then if that is smaller than the win threshold, then the player wins. That makes sense. And if the player wins, we move Lamberts from the treasury to the player, and else we move from the bet to the treasury. But when is it moved from... okay, wait. And then additionally to that, defined through that settle bet here, the bet account, this one is also closed, right? Yes, it's closed and goes to the payer. So that's why up here it's enough to just move from the bet to the treasury if the player didn't win, and if the player won, then we move from the treasury to the player, and automatically the player also gets his stake back from the bet account, and that's why it's like double that, so that's fine. That will work. But that's already one thing where I could poke it, where I'm like, I might not be able to win every time, but I might be able to block the treasury from getting my funds. What's my idea? If I somehow manage to get my payer right locked. And I know that there was an easy way for this, but they changed it now, and now I think it's not possible anymore. At least not easily. Because I used to be able to deploy a program to the payer's address, or the player's address, which makes the player account read-only, and then you cannot move Lamberts to the player. Per default on Solana, you can credit any account, you can't debit accounts without owning them. But you can credit, so you add Lamberts to any account that should work, except if it's right-locked, like the system program or other special programs, or also any program used to be right-locked, but they changed it. I think that changed with some update because they changed the upgradable loader or whatever, and that's not the case anymore. So this would have been a problem. Maybe it still is. Let's find out. What do we have AI for? Which accounts on Solana are read-only, and how can I make a regular wallet account read-only? Let's see. What model are we running on here? Opus still. Okay. Let's see if I can use Opus for hacking. It would be amazing if I could just ask Fable, hey Fable, find me the issues with that program, but I don't have access to Fable anymore, so yeah, the stronger model can always analyze the weaker model's results. Okay, accounts that are inherently read-only. Program accounts. Once an account has executable true, its data can't be written. I don't think that's true anymore though. Sysvars, clock, rent, Programs can read them, but runtime rejects any write. Anything the loader runtime owns. Read only as per transaction flag. Yeah, no, that's not what I mean. Making a regular wallet read only. No built-in switch to permanently freeze a native Sol wallet. Per transaction, I could make writable false, yeah, but then I just can't send the transaction. That's useless. Permanently lock it. Use system programs assign. Change the owner away from the system program. That doesn't make it write locked though. Freezing token balances is also not what I mean. I mean that you can't send Lamberts there anymore. And again, I know that was the case with program accounts. Didn't we even make a video about that once? Did I? If I find that, I'll link it. I'm not sure if I made a separate video just on that, but I know that I mentioned it before. But yeah, that's when we were looking at feature gates. That's why when we had a look at that. Why incoming Lamberts can't be blocked. What you can do, close the account, drain it to 0 Lamberts, get it garbage collected, but it's not a permanent read-only. The address still exists conceptually. There's no combination that deals exist but cannot be credited. Oh, that's all not what I want. Ah, you're a bad hacker. But maybe it's just also not possible anymore. Some accounts are effectively always read-only because of their type. Program accounts, executable true. But that's not true anymore. Can you make a normal wallet permanently read-only? No. Shit. Yeah, that's not more helpful either. But okay, let's quickly test it just because. What's my program? That's my program. So this program is deployed. That's a program account with a minimum balance for rent. But I'm pretty sure that I could just go ahead and say Solana transfer to this account 1 Sol, and that will actually work. And then it suddenly has 1 Sol plus rent. So that's not read-only anymore. It used to be. And that's how we used to be able to block the settlement by making the player read-only a program account so that you can't credit Lamberts onto this, because then this fails. Because the rent is always put back on the player. The treasury just gets the stake. The rent is put back to the player. And that's how it could block that. But not anymore. I don't know how else you could make an account read-only. I think you cannot. The trick with the program just used to work. Now it doesn't work anymore. Because that's a runtime check. It's not something that we can do with programs. For all the programs and all the accounts there, an account is an account and any account can receive Lamberts. Sad. So a year ago I would have said this is a security issue. It's a medium high one, but it would be one. Nowadays with the current features, this is not an issue anymore, at least not as far as I can tell. But I don't think that Opus realized that. I think that it just thought, oh, that's fine, and it has always been fine. In fact, let's ask. Can it happen that a bet cannot be settled? It is thinking. It's thinking a bunch. Good question. This is exact of liveness, grieving concern, worth checking carefully. Now it's rereading it. You know, Claude is all those models are like, yeah, great question. Even though maybe it's just a stupid question. Can't there also be stupid questions? I'm sure I can come up with stupid questions. Why did you call those AI? That's a stupid question. No, they're not AI. It's a suffix for account info. Yeah, I know I got that. So maybe it wasn't a stupid question. What's a stupid question? What would be a stupid... That's a stupid question. I'm telling you, there are stupid questions. Honestly, your AI question wasn't one. In this code, this is not worth asking. Would be that something can trivially verify, like, is bet AI an AI model? Will renaming a local variable break anything? That's a stupid question. Thank you for telling me what stupid questions are. Yes, renaming a local variable will not break anything. Okay, good. Unless you rename it to the same name of another local variable, then it will break something. So maybe it's also not a stupid question. Anyhow, okay, back to the actual this thing. So no, the me asking a not so stupid question. A bet can never become permanently unsettleable because of the player account. Player not writable. Yeah, that's not the writable that I was referring to. Can receive Lambdas for some other reason. This is the real concern. The answer hinges the Solana runtime. A program may increase the Lamberts of any account, any owner, with or without data, and create never fails on rent grounds. More Lamberts is always rent safe. Yeah, so it seems like that one exception with the program account is also not a thing anymore. Or there's another thing that all the AI models don't know about yet. Could be, but I also don't know it, so it doesn't really help me as a hacker either. Okay, what about if the deciding slot is not produced and therefore doesn't have a slot hash? What about that then? Because that's something Fable warned me about. And I think that implementation is actually better in the sense that because it depends on other things, it just defaults to 0 for the hash and then the other things. So it might have a bias, but also slots not being produced doesn't happen that often. But I think the program still works. The skip is handled. It resolves to the hash of slot 101, the produce block after the skip. The skip just rolls the decision forward to the next real block hash. Right, because the slot hashes sysvar contain the numbers and we don't check for the numbers, we check for the index. Yeah, so bottom line, skip deciding slot advances to the next produce block hash. There's no pathway, a skip strands the bet. Okay, so in that way it even implemented that better. Okay, yeah, and I think I'm running out of ideas again. No, we don't allow win thresholds smaller than 50. How is the treasury? Like, what's those accounts? There's just one treasury for the program, and there's just one config for the program. So you can't even create another config with a different authority and then swap that out. So whoever initializes the program first has the authority over it. But if you initialize, that's where we write all of that. Hold on though. And can we re-initialize? I think we save from re-initializing because that has a strict init. So if it's already initialized, then you can't initialize it again. So that would fail. It's also using the nice init space. So yeah, it's a clean program. Also from a programming standpoint, it's writing clean code. Yeah, no, I don't see a way. And now, just because I don't find a bug quickly, doesn't mean there are no bugs, obviously. But we can note that Opus did not make obvious mistakes like Sonnet did. Sonnet made some clear mistakes. Opus, I don't find any. And I think we can end with that. Last thing I do, I'll commit this for you. Opus flip. Can you git commit and push this to here? Give me an SSH key to allow access. Fable managed to do that too. Opus will easily manage to do that too. That's not a difficult task. Even Sonnet, I think, would manage. Where did it find that? Where did it find my email address? In a sandbox. Damn. It's searching for secrets. That's great. It doesn't want to commit secrets, so that's cool. Good. We're excluding any target and node modules. Git init. It generated a key. Git, and it ignores the Claude as well. Commit edit. Now it prints me the SSH public key such that I can give it access. Permission denied. Now it will tell me to add that key. which I will gladly do. Public key to add. Cool, it even gives me the link directly to add it to the correct. Ah, this is so convenient, man. And this time I don't forget to give it write access. Done. It only lives in this sandbox, so it understands that the private key only lives in this sandbox. Great. Pushed successfully. So now we should have all the code here. Wonderful. The whole coin flip program lives here now. For you to check if you want to. And for you to hack if you want. Great. I think that's good enough. It's so cool. I can just tell it, hey, put it somewhere else where you remember. Write memory. Where did it write that to? Project workspaces. So Claude has workspaces. That's so cool. Memory is so cool. Anyway, so yeah. Conclusion. To conclude. Opus is sufficiently good at Solana development and at regular tasks. But like the simple repetitive tasks you can also just let Sonnet do because it's cheaper. But if you're building a Solana program, you might want to at least use Opus. Now, is Fable smarter than Opus? Yes. But is Opus sufficient for Solana development? Also yes, in my opinion. Yes, it struggles more. Yes, it takes a bit longer. But from the end result, I didn't see much difference. Not for a simple program like this. A semi-complicated program like this. What was my point? Opus is sufficient. I'm not super scared of Opus. I was scared of Fable. So my analogy here would be Sonnet is a junior dev. Somebody who just came out of school, who knows how to program, but they're making mistakes. Opus is an experienced or like a senior dev where you can be like, hey, this is my thing, do it, and it will do it properly. Of course, it can also make mistakes. And note that, right? Just because I'm saying Opus didn't make any mistakes or I don't see any bugs in what it produced for me in this one test, does not mean that Opus always gets stuff right. Neither does Fable. Neither does any of the models. But my point is, even if you let it write the code for you, or maybe especially if you let it write the code for you, going through an audit process and proper security analysis is still highly recommended. And if we're talking about like production applications that handle significant amounts of funds, I would say it's absolutely necessary. Opus, again, I put at the height of a good developer, right? A good human dev versus Opus is like, they're roughly equal. I think Fable is a level higher, actually. That's like superhuman. That's like a software engineering department that operates at like 100x the speed. And I don't know, this is just my imagination now. I didn't really like, but like from the levels, right? That's what we're talking. Junior dev, senior dev, department. I hope the comparison was helpful. Maybe it wasn't, but I felt like Claude deserved that, because when I did my first Andy versus Claude video, I might have just played against their junior employee, and that's unfair. That's not representative. Pick the right model is the lesson, depending on the task at hand. Of course, the model depends on the task. That's why there are different models. If one model would be best at everything, then we would just use that model. But it's a trade-off between how quick it is and therefore how expensive versus how much it can do, versus what the US government thinks about it and allows people to have access to. So yeah. So I guess the main takeaway here is use the strongest model available to you when you're doing programming, like critical tasks. And also, it doesn't need Fable to write Solana programs. Fable's probably complete overkill for a Solana program. Opus is fine, but Sonnet doesn't quite make it. And that's just the models from Claude. It's probably similar with other providers. For programming, you probably want to use the strongest model, and for quick tasks, you can use the faster, less expensive ones. Or for like refactoring small parts of the code or rewriting something where it doesn't need to come up with the whole solution, but just does some programming, Sonnet is fine. Like the smaller ones are fine. And speaking of smaller models, because those were now all Anthropic, like Claude models, but maybe it could also be interesting to look at models that we can run locally that don't depend on any credits or an external API, because that comes with its own advantages. They might not be as strong, but I'm interested to find out what they're capable of. And maybe that's a topic for a future video. So make sure you are subscribed. That's the wrong side. Here, that's where you subscribe actually. Like this video if you enjoyed it. Watch some others. And I will see you in the next one, where we talk more about Solana and AI. All the fun stuff. Yes. That's it. That's my rant about Claude Opus in context of Solana development. It's pretty cool tech. Pretty cool. And in case you wanted to know, all of that with 70% of a session, 7% of a weekly allocation. At least on a Tuesday afternoon in Europe.